Hello students, once again welcome you to GK's Applied Maths classes. Today we are going to do a linear programming problem, and this is the part 2 of the video, where in part 1 we have discussed various types of questions of linear programming problem. Today what we are going to do is we are going to concentrate more on ML Aggarwal questions, that is exercise 15.1 and exercise 15.2. I will do question number 9 to 12, okay, as it will take more time, so we'll see how much we can do, okay. So straight away we'll get inside the problem. Now, first of all, just to have a recap of what a linear programming problem is, let me give you an introduction. I will also put the link of part 1 video in the description box for you to refer to it, okay. So let's get into this. A linear programming problem should have 3 fragments. The first one is the optimization function. So that is, either you can have maximize or minimize. Z, it is denoted by Z, and it's a linear equation. That is why it's called linear programming, right? It's a linear equation where x and y are the variables. We can call it as decision variables. It's called decision variable. So a linear programming problem should definitely have an objective function. So this is called an objective function, either to maximize or to minimize. Then it should have a constraints. So you can have any number of linear constraints, like say for example a1x plus b1y is less than or equal to c1, or you can have x is less than or equal to c2, you can have y is greater than or equal to c3, and so on. You can have any number of constraints. They are all constraints. Then it should have a non-negative constraint. Non-negative constraints. That is, x is, every LPP should have x greater than or equal to 0, y greater than or equal to 0. Then I have introduced you some words called feasible region. There is feasible region, the overlapping part. The overlapping region of the constraints is called the feasible region. Okay, it are 2 types of feasible region. One is bounded, the other one is unbounded. As and when situation comes, we'll go back to it again. I have done all these a problem from each type of bounded and unbounded in part 1. Okay, and then you have something called the corner points. Okay, so these terms I'm reintroducing you to it. Okay, so now we'll get into the problem and see how we solve these problems graphically. Now the first question, this is exercise 15.1, first question. So what is the first question here? A tailor A and B earns rupees 300 and rupees 500 per day respectively. A can stitch 6 shirts and 4 pairs of trousers, while B can stitch 10 shirts and 4 pairs of trousers per day. To find how many days should each of them work, and if it is desired to produce at least 60 shirts and 32 pairs of trousers at a minimum labor cost, formulate this as an LPP. He has not asked me to solve, he has only asked me to formulate an LPP. So first let's look at the tailors. So the 2 tailors are A and B. So let me make a note of it. So this is A and this is B. There are 2 tailors, A and B. Then what do? They stitch shirts, right? So let me write shirts, and they stitch trousers. Okay, so I call it trousers and pants. Okay. Now A stitches how many? 6 shirts and 4 pairs of trousers. 6 shirts, I use the same word, trousers. So and stitches 4 pairs of trousers. Now what does B do? B can stitch 10 shirts and 4 pairs of trousers. So first, whatever data is there, first you take the data. That's very, very important. Then how much it cost? It cost rupees 300 and 500. Okay. So what is the cost? The cost for the shirts and trousers. The two tailors A and B earns rupees 300 and 400 per day. For stitching, how much? For stitching shirts and trousers. So he earns 300 per day. This man earns rupees 400 per day. Okay. This is the labor cost. Or this is what he earns. Okay. This is what the two tailors A and B earns per day. Okay. Now, it is desired to produce at least 60 shirts. At least means greater than or equal to 60 shirts and 32 pairs of trousers. So greater than or equal to 32. So I have to formulate this as an LPP. So what you will do? What is the question? How many days? So let tailor A takes X days and tailor B takes Y days. This is my decision variable. Tailor A takes X days and tailor B takes Y days. Now what is the objective function? The objective function is to minimize Z equal to minimize the cost, right? The question is to minimize the cost. The cost is 300 per day, so it is 300 per day, but it is work for X days, which is 300X plus 400Y. Y subject to, what is the constraint? Subject to, what is the constraint for the shirts? What is the constraint? 6X plus 10Y is greater than or equal to 60, or you can say this is 3X plus 5Y is greater than or equal to 30. So this is my first constraint. What is my second constraint? 4X plus 4Y is greater than or equal to 32. This implies it will be X plus Y greater than or equal to 8. Call this as 2. Now what's the non-negative constraints? X greater than or equal to 0, Y greater than or equal to 0. Now you can see you have an objective function, you have two constraints, and you have a non-negative constraint. So I have formulated this problem into an LPP. The question is only to formulate, so I only formulated it. I don't have to solve it as per the exercise, as per the question. Okay. If you want, you can try it by solving graphically. There's no harm. But in the exam, if they say formulate, you write one. You do only formulate. Don't solve it. Let's go to the second question. Now, what is the second question? The second question is, a small firm manufactures two items. What are they? Necklaces and bracelets. Okay, they manufacture two items, necklaces and bracelets. So let me write those items. So it is necklaces and bracelet. That they are manufacturing two items. The total number of necklaces and bracelets that it can handle per day is 24. It cannot exceed 24. That is total number. So let me take this as X and take this as Y, and this is the number of items. Okay, number. It cannot exceed 24 because he has said is at most 24. At least means greater than or equal to, at most means less than or equal to. And he says it takes 1 hour to make bracelet and half an hour to make necklace. So what is the time? The time is, it takes 1 hour for the bracelet and it takes half an hour for the necklace. Like this, if you make a table, it becomes easy. And the maximum number of hours, total time available is only 16. So it cannot exceed 16. I'm left with only 16 hours. So you cannot have more. So it should be less than or equal to 16. Okay. And if the profit on the necklace, so I have to use the word profit. So what is the profit? The profit on necklace is 100 and the profit on bracelet is 300. What is the question? Formulate an LPP for finding how many of each should be produced daily to maximize the profit. Okay, so what I do? So let X and Y be the number of necklace and bracelets, okay, manufactured per day. This is the number of manufactured per day. Now what is the question? According to the question, I have to maximize. Maximize what? I have to maximize the profit. So what is my profit? Profit is given here. 100x plus 300y. Subject to, what are the constraints? Subject to, what are the different constraints? One is the number it can produce per day. What is that? Total number of items cannot exceed 24. So that is the first constraint. What is my second constraint? My second constraint is time. Half of x plus y should be less than or equal to 16. If you want, you can simplify this. You can write x plus 2y is less than or equal to 32. Call this as second. Now non-negative condition. X is greater than or equal to 0. Y is greater than or equal to 0. So you have formulated an LPP. It is not required for you to solve this. You just have to formulate the LPP. I hope this is clear. Okay. All that is required is whatever data is given, put it in a tabular column. Automatically you will get the constraints. It's very, very simple. Now let's go to question number 3. What is question number 3 says? Now question number 3 is, a furniture dealer deals in only 2 items. What are the 2 items he is dealing with? He is dealing with tables and chairs. He is dealing with tables and chairs. He has 20,000 to invest. So since he is dealing with tables and chairs, let me write tables. And he is dealing with what? He is dealing with chairs. Okay. He has 20,000 to invest and a space to store at most 80 pieces. Okay. He has only 20,000 to invest. He does not have more. He has only 20,000 to invest. Okay. So his investment, it cannot exceed 20,000. His investment cannot exceed 20,000. Not only that, space. Okay, the space that is required to store the item is only 20 pieces. So is 80 pieces. It cannot exceed 80 pieces. At most 80 pieces. Right? Now the table cost him 800 and chair cost him 200. So that is the investment, right? It cost him 800 and the chair cost him 200. Okay, so the investment is 800 on table and 200 on chair. One table cost 800, one chair cost him 200. But he can invest how much? He can invest only 20,000. Okay. Now he sells it. What is the selling price? The selling price is 950 and this is 280. Assume that he sells all the items that he buys. Formulate this problem as an LPP. You have to only formulate for maximum profit. Okay, so what is profit? Profit is given by selling price minus cost price. So this is selling price. Investment is my cost price. So I want to maximize, right? So maximize profit Z equal to, what is 950 minus 800? 150x plus 280 minus 200, 80y. So I have got the constraints. Okay, I have got the objective function. So what are my constraints? Subject to, let the number of pieces be x and y. Okay, so subject to what? 800x plus 200y is less than or equal to 20,000. If you want, you can simplify this. It will be 4x plus y is less than or equal to 4, I think it's 50, right? Is less than or equal to 50. I think I cancelled 2, so it is 100. I'm sorry. So this is 1. Correct? Now what is the other constraint? X plus y is less than or equal to 80. Actually, this is my investment constraint, and this is my space constraint. Okay? And you have the non-negative constraints. What is that? X greater than or equal to 0, y greater than or equal to 0. So what have you done? You have formulated the LPP. Okay. So with that, we completed exercise 15.1, where there are 3 questions. Here we deal only with formulating the LPP. We don't solve it. Okay. Now let's go to the next one. This is exercise 15.2. Exercise 15.2, question number 1 to 8. Equations are given directly. I think you can solve it. Okay. Maybe later, if you get time, we'll try to do those problems, but they are very, very simple. Because the equations are given, there's no hassle. Refer to the part 1 of the video. You will know how to draw the graph. Now what I will do here is I will do only the word problems where we formulate the LPP and also solve the LPP. Okay. So we will concentrate only from question number 9 to 25. Okay. Since there are 25 questions, today we will do only 4 from exercise 15.2. So let us start with this. What is the question? A manufacturer considers, okay, a manufacturer considers that men and women workers are equally efficient, and so he pays them at the same rate. He has 30 and 70 units of workers and capital respectively. He has 30 units of worker and 70 units of capital, which he uses to produce 2 types of goods. What are the 2 types of goods? The 2 types of goods are A and B, right? The 2 types of goods are A and B. So let's take that first. 2 types of goods are A and B. To produce units, okay. To produce 1 unit of A, 2 workers are required and 3 units of capital. So I need, this is W stands for worker, C stands for capital. So to produce 1 unit of A, what is required? You need 2 units of worker and 3 units of capital, correct? This is what I am dealing with. Is that clear? Now, while for B, for 1 unit of B, what is required? 3 workers and 1 unit of capital. 3 workers and 1 unit of capital. Okay? But he has also said he has only 30 units of worker. So you cannot have more than that. And he has only 17 units of capital. So only 17 units of capital he has. Correct? And if A and B are priced at 100 and 120 respectively, okay, how should he use his resource to maximize his total revenue? So what is the price? The price is 100 rupees and 120 rupees. This is the cost. Okay. In fact, this is the revenue for him. Okay. This is what he sells at. So now what you will do to maximize the total revenue? So maximize Z equal to, what is the total revenue? 100x plus 120y. 100x plus 120y. Okay. 100x plus 120y. And then subject to, what is the subject to? What are the constraints? 2x plus 3y is less than or equal to 30, first constraint. And what's the other constraint? 3x plus y is less than or equal to 17. Second constraint. X is greater than or equal to 0, y is greater than or equal to 0. So this is a LPP I have formulated from whatever is given. Of course, you can say x and y be the number of units of A and B. That you have to declare always. X and y be number of units of A and B. Now he has not only said formulate the LPP, he has also told me to solve it graphically. Since he has said to solve it graphically, let's do the usual thing. I will take 2x plus 3y equal to 30, and I will draw the x-axis and y-axis, and before that I will do the calculations. X is 0, y is 10, y is 0, x is 15, and then you have 3x plus y equal to 17. So you get x is 0, y is 17, y is 0, x is 17 by 3. I think all done. Okay. Now I am going to draw the graph. Now how do I draw the graph? For that I'll take a straight line first. Let's make it clear. Copy, paste. Okay. This is my x-axis and y-axis. This is my x-axis and y-axis. Now the maximum value is 15 and maximum value of x is 15 and maximum value of y is 10. So I'll just draw a rough diagram. 0 comma 10. So you are having 17 also. Okay. So this is 0 comma 10 and 15 comma 0. Okay, please plot it properly, you'll get it. Okay. So let me draw the line. So this is the first line. Okay. So what is the equation of this line? The equation of this line is 2x plus 3y equal to 30. Now I have to draw the next one, 0 comma 17. So 0 comma 17 is here, 0 comma 17, and 17 by 3. 17 by 3 is like 5 point something, right? So it will be somewhere here. So 17 by 3 comma 0. So let me draw the line. So if I join this, I get the graph perfectly. So this is actually this is 3x plus y equal to 17. Now both are less than constraints. I think you know how to find the feasible region. Substitute origin. If you substitute origin, you get 0 less than or equal to 30. Substitute in 1, which is true. So it is towards origin. Okay. So towards origin, towards origin, right? The pink color lines. And if you substitute origin again in 2, you get 0 less than 17, which is also true. So it is again towards origin. So this is towards origin. So where do you see the intersection? The intersection is seen here, right? So this is the feasible region. So this is the feasible region. That's some shading problem. This is the feasible region. O, A, B, C is the feasible region. So I will write O, A, B, C is the feasible region. And what type of feasible region it is? It is bounded. So what are the corner points? I say just write CP, just in short, corner points. O, that is 0, 0. A, it is 17 by 3, 0. And B can be got by solving these two equations, okay? And I have got it as 3, 8. And C is 0, 10. And C is 0, 10. Now take Z. What is my Z function? My Z function is here 100x plus 120y. Now substitute, you get Z is 0. You get Z equal to, when you calculate, I think I'm getting 566.5, which you can do. I don't want to waste my time. And here I get 1260. And here I get Z equal to 1200. And since the question is to maximize, the maximum value of Z is what? The maximum value of Z is 1260. So you can write maximum profit. Always write the answer correctly. Maximum profit is rupees 1260 for 3 units of A and 8 units of B. 3 units of A and 8 units of B. Very simple. So you not only formulate, but you are also solving the linear programming problem. If you are very careful, you will get it very easily, and it's a very scoring place. Okay. Now let's go to question number 10. Now this is question number 10. How do I do question number 10? Now question number 10 again. A manufacturer produces nuts and bolts. Okay. Since he produces nuts and bolts, it takes 1 hour of work on machine A and 3 hours of work on machine B. Okay, so he produces what? He produces nuts, and then he produces bolts, and there are 2 machines. What are they? A and B. Okay, a manufacturer produces nuts and bolts. It takes 1 hour on machine A, 1 hour on machine A, and 3 hours on machine B. 3 hours on. Okay. It takes 1 hour on machine A and 3 hours on machine B to produce nuts. It takes 3 hours on machine A. It takes 3 hours on machine A and 1 hour on machine B to produce bolts. And it earns them a profit. What is the profit? It earns them a profit of, I'll put the profit here. It earns them a profit of 17.5 per package for nuts, and 7 per package, okay, for the bolts. So how many packages are to be required to maximize the profit if he operates the machine for at most 2 hours? So both the operations are operated for 12 hours. It does not operate more than that. So what you will do? Let X and Y be number of packages of nuts and bolts. Now the question is to maximize the profit. So what do you write? Maximize Z equal to 17.5x plus 7y. 17.5x plus 7y. So this is the objective function. 17.5x plus 7y. Subject to, what is the constraint? Subject to, what are the constraints? X plus 3y is less than or equal to 12. First constraint. What's the second constraint? 3x plus y less than or equal to 12. That's the second constraint. What's the third one? It's a non-negative constraints. X greater than or equal to 0, Y greater than or equal to 0. So I have formulated the LPP. Very simple. The moment you get this chart done properly, rest of the things are very, very simple. I hope you understand that. Now how do I calculate? First I'll take x plus 3y equal to 12 and x is 0, y is 4, y is 0, x is 12. Then I have 3x plus y equal to 12. So what I will do? I will take x is 0, y is 12, y is 0, x is 4. Now I am going to plot the graph. Now how do I plot the graph? This is my x-axis and this is my y-axis. So let's try to move it. It's not moving. So this is x-axis and y-axis. So we are going to plot the graph. What is the first graph? 0, 4. So this is, this is 0, 4 and it is 12, 0. 12, 0. Correct? Now I have to plot the graph. How do I plot the graph? So this is the graph. This is the first line. Okay. Let me extend my x-axis a bit. Okay. So what is the equation of this line? The equation of this line is x plus 3y equal to 12. Now the next one is 0, 12. 0, 12 is here. 0, 12 and then 4, 0. So roughly 4, 0. So I'll just copy it. So let's draw this line. Very nicely it comes. So what is this actually? This is x plus 3x plus y. 3x plus y equal to 12. Okay. Now since both are less than, just like the previous problem, origin will satisfy both. 0 will be less than or equal to 12 for both the equations, both. So it will be towards origin. So the feasible region is this. Okay. So this is my feasible region. What type of feasible region? O, A, B, C. So I will write O, A, B, C is the feasible region. And what type of feasible region? It is bounded. The feasible region is bounded. So what are my corner points? The corner points are origin, that is 0, 0. What is my A? A is 4, 0. B you can get by solving these two equations. We'll come to that later. C is 0, 4. Now B, what is B? B I am getting it as 3, 3. Okay, B is 3, 3. Yeah, 9 plus 3, 9 plus 3 works. So what is Z? My Z function is, where is Z function? It is 17.5x plus 7y. So my Z will be 0 here. And what is the value of Z? The value of Z will be 70. And what is the value of Z here? You can just do the calculation. It is 73.5. And what is the value of Z? Z is 28. And since the question is to maximize the profit, so what's the maximum profit? The maximum profit is rupees 73.5 for what? For 3 packets of nuts, and 3 packets of bowls, right? Yeah, bowls. So that's the answer. Very, very simple. Only thing, you have to be focused in plotting the graph very carefully, and it is like a gift. You get easily 4 to 5 marks in board exam if you are very good at LPP. Now let's go to the next problem. Now this is question number 11. Now what is question number 11 is saying? A small firm manufactures gold rings and chains. What do they manufacture? They manufacture gold rings. So let's make a note of that. They manufacture gold rings and gold chains. So gold is not required. So they manufacture rings and chains. Okay, the combined number of rings and chain manufactured per day is at most 24. So this is the number they manufacture. How many they manufacture? We don't know. So I call it X and Y, but they cannot manufacture more than 24. So that is what the question is saying. The combined number of rings and chain manufactured per day is at most 24. It cannot exceed 24. Okay. And it takes 1 hour to make ring and half an hour to make chain. So what is the time taken? The time taken is, it takes 1 hour on the ring and it takes half an hour on the chain. Okay. And the maximum number of hours available per day, they can work for maximum 16 hours, not more than that. So it's less than or equal to 16. If the profit on ring is rupees 300, so we have the profit. See, I did not do anything. I just collected all the data and put it in a tabular form, nothing else. Profit is 300 and chain is 190. Okay. How many of each should be manufactured so as to maximize the profit? Okay. So let X and Y be number of rings, gold rings of course, and chains manufactured. Chains manufactured. So what is the question? What is the objective function? Maximize or minimize? Here you said maximize the profit. So maximize Z equal to, what's the profit here? 300x plus 190y, subject to, what is the constraint? Subject to, the first constraint is the number of items produced. It cannot exceed 24. That is what the question is saying. And the second constraint is, he is saying that time. Okay, 1 hour for X, 1 hour for ring, but there are X rings produced. So X into 1 and half into Y, it cannot exceed 16. It cannot exceed 16. So call this as 2. If you want, you can take LCM, otherwise you can just leave it. It's an even number, I don't have a problem. X is greater than or equal to 0, Y is greater than or equal to 0 is a non-negative constraint. If all these 3 are there, full marks, okay? First you get the marks for the writing the constraint. Once this is right, the rest of the thing will be right, okay? Now what do you do? First you take X plus Y equal to 24. So X is 0, Y is 24. Y is 0, X is 24. Then I have X plus Y by 2 equal to 16. So what is this? X is 0, Y is 32, Y is 0, X is 16. So now it's time to plot the graph. So let's take the x-axis. This is my x-axis. I don't know this. I don't say manufacture. Okay, now y-axis. This is my x-axis and this is my y-axis. Let's plot it. 0, comma 24. So where is 0, comma 24? 0, comma 24 is somewhere here. 0, comma 24. And I have 24, comma 0. 24, comma 0 is right here. Now plot the graph. Perfect. So I will change the color if you want. Make it yellow. Okay. It's too light. Blue. So this is x plus y equal to 24. What's the next one? It is 0, comma 32. So 0, comma 32 will be here. 0, comma 32. And then you have 16, comma 0. So 16, comma 0 will be somewhere here. 16, comma 0. Now let's plot the line. Okay. Let me give it a nice red color. So these are the two lines, and this is actually x plus y by 2 equal to 16, and both are less than constraints. So if I substitute origin in 1 and 2, okay, both will satisfy. You will get 0 less than 24 and you will get 0 less than 16 if you substitute in 1 and 2. So that means it is towards origin. So what is the overlap towards origin? This is the overlap towards origin. Okay. So this is the overlap towards origin. This is my feasible region. So what is the feasible region? My feasible region is O, A, the color is not correct. O, A, B and C. So the feasible region is O, A, B and C. So now let's write. The feasible region is O, A, B, C. And what type of feasible region? It is bounded. Where, what are the corner points? Corner points are origin. And what is A? A is 16, 0. B I have to find. C is 0, 24. Now B, how do I find? B I find it with 8, 16. 8, 16. That we can always calculate it. B is 8, 16. So what is the Z value? My Z is actually 300x plus 190y. So Z equal to 0, and I get Z equal to what? I get Z equal to 4800 and Z equal to 5440 and Z equal to what? 4560. You can calculate it. The question is 4560. The question is to maximize, right? The question is to maximize. Since it is to maximize, what you will write? The maximum profit is rupees 4560 for what? For making 8 rings and 16 chains. Okay. Now let's one last question. A company produces 2 goods A and B. A company produces 2 goods A and B. Okay. What are they? The company produces 2 goods A and B. First let's write that. Company produces 2 goods A and B. That requires gold and silver. Okay. What does it require? It requires gold. 2 types of goods that requires gold and it requires silver. It requires gold and silver. Now, each units of A requires 3 units of silver and 1 units of gold. Each units of A requires 3 units of silver and 1 units of gold. While B require 1 units of silver, and 2 units of gold. Okay. So from the data I have tabulated it. Now what I should do? The company can use 9 grams of silver. The company can use at most 9 grams of silver. It cannot exceed 9. And it cannot exceed 8 grams of gold. Correct? If each unit of A brings them a profit, so here you are talking about profit. Profit is rupees 40 and type B is 50. Find the number of units of each type of the company. So let X and Y be the number of units of A and B. Now what is the question? The question is to maximize the profit. So what is that? Maximize Z equal to 40x plus 50y subject to, what is the constraint? The constraint is subject to x plus 2y less than or equal to 8 and 3x plus y is less than or equal to 9, x greater than or equal to 0, y greater than or equal to 0. Is that clear? 3x plus y less than or equal to 9. Okay, now x plus 2y equal to 8. Plot the table. X is 0, y is 4, y is 0, x is 8. Then you have 3x plus y equal to 9. You have x is 0, y is 9, y is 0, x is 3. So now you have to plot the graph. X-axis, this is my x-axis, and then you have the y-axis. X-axis and y-axis. Now how do I plot the graph? 0, 4. 0, 4 will be 0, 4 is somewhere here. So this is 0, 4 and 8, 0. 8, 0. Plot the line and you get automatically the straight line. So what is the equation of this line? The equation of this line is x plus 2y equal to 8. Now 0, 9, this is 0, 9 and 3, 0. So I'll plot this as 3, 0 and you get this line. Straight away you get this. This is x plus 3x plus y equal to 9. Okay, let me just stretch this x-axis a bit. Okay, that's fine. Now, since both are less than constraint, 0, 0, if I substitute in 1 and 2, what will happen? You get 0 less than 8 and you get 0 less than 9. Both are true. So it is towards origin, right? So towards origin means what's the feasible region? So this will be my feasible region. Okay. Let me just shade it. So this is my feasible. What type of feasible region it is? It's bounded, right? So O, A, B, C. So you can say O, A, B, C is the feasible region. And what type of feasible region? The feasible region is bounded. So what is the corner points? The corner points are origin. A is 3, 0. B I don't know. This is C. This is C. C is 0, 4. C is 0, 4. I'm sorry. B I have to find. C is 0, 4. Now what is B? B is nothing but 2, 3. Now find Z. What is Z values? The Z values are 40x plus 50y. Now substitute. Z equal to 0, Z equal to 120, Z equal to what? It is 230 and Z equal to 200. Since the question is to maximize, what's the maximum value of Z? The maximum profit is rupees 230 for what? For making 2 units of A, 2 units of A and 3 units of B. So we have completed 12 questions till question number 9 to 12 from exercise 15.2. We will be continuing with more problems in the next video. Kindly subscribe to my channel and also click the bell icon to get notifications. Thank you for your support. See you again in the next class. Have a lovely day. Bye-bye.